Relax! I just need help finding a file.
Practically speaking, the internet is a physical, subterranean architecture. It's a vast network of storage banks holding frozen snapshots dating back decades. In the 1990s and 2000s, putting things on the internet was a manual act. You moved files from a local drive to a specific server. The moment that work was fixed to a digital medium, copyright attached to it instantly. In 2009, an operation called the Common Trawl began. It deployed automated crawlers to take point-in-time snapshots of the written web, compressing billions of pages into archive files. Webmasters permitted these crawlers specifically for search indexing. The goal was discoverability, letting a search engine read the text so people could find the site. But remember, crawlability is not the same as a license. Webmasters who consented to being indexed for a search engine never authorized a corporation to take a permanent private copy of their property. The tech industry defends the use of this data by characterizing the internet as an ambient, ownerless pool of information. Under this framing, individual creator consent is impossible to secure because they claim the data is effectively anonymous. This characterization misrepresents how database storage functions. The dataset is a highly structured database where every file is mapped to its origin. The untraceable nature of training data isn't an accident. It is the result of a deliberate, auditable engineering choice. The Common Trawl stores snapshots and compressed blocks called work files. These are hosted on Amazon S3. The billions of compressed files are organized by a master lookup table called the CDX index. This is a raw CDX index record for a single scraped file. It contains the exact provenance metadata the system logs during a crawl. The system records the registered URL and domain of the original creator. It also logs the exact timestamp of the capture and the S3 byte range offset coordinate. These coordinates act as precise physical addresses. The system knows the exact location of every single scraped byte. Provenance is the organizing logic of the corpus. Intermediary steps like the C4 dataset or the pile sit between the raw crawl and the final LLM training. These are known as derived datasets. Deriving a dataset is a mechanical extraction and copy operation. Engineers pull specific files out of the archive blocks using the CDX index. During extraction, engineers run automated scripts to strip away the CDX metadata. The URLs, timestamps, and coordinates are deleted from the record before the text is passed to the final training model. This script is the moment legally owned property is converted into an anonymous token. The capacity to conceal a name proves the name was known. You don't build scripts to obscure data that isn't there. In 1998, Alyssa Milano successfully enforced her rights regarding unauthorized images of her on the early web. She forced live server hosts to delete the non-consensual files, proving that reachability is not a license. The Common Trawl bypassed these protections by operating as a point-in-time snapshot. It captured the illegal data during the precise window it was live, and froze it permanently into the archive. Legally enforced takedowns only act upon the live origin host. They do not reach the distributed work archive files sitting in S3 buckets. Because the ingestion pipeline lacks per-item rights checks, this forbidden material is swept directly into model training. The pipeline decouples data from its legal status. By automating the ingestion of billions of files, the system ensures that a work captured in a snapshot remains in the dataset regardless of its subsequent removal from the live web. Scrapers often argue that if a file is freely accessible at a URL, it is free to use. This was the same defense used during the A&M Records versus Napster lawsuit in 2000. The court ruled that making someone else's property freely available online does not transfer a license to the downloader. The law did not change between a teenager downloading an MP3 and a corporation downloading the internet. Only the scale of the enforcement changed. The addressability of Bistievet is a technical reality that can be demonstrated directly on the servers. Using the exact byte coordinates found in the index, we can execute an S3 range request to pull one specific file out of billions. The data is instantly retrievable if the keys are not stripped. Dropping every flagged image or copyrighted file costs the model essentially nothing computationally. The code simply skips the coordinate. The ingestion of this data is a calculated business decision. The scale of the theft is a choice to prioritize cost over compliance.
Come and crawl, we see you there. We've got some work to do now. Come and crawl, you took the web but didn't pay us, so now you said you were a library, a quiet, friendly front. But we looked inside the S3 vault and saw the whole big stunt. Unmask the beast, roll off the sheet. It's just a corporate giant on a taking spree. You didn't crawl for search, you didn't crawl for free. You dug the hole, you took the souls and sold the pedigree. Come and crawl, you left no tracks, a ghostly profile low. You stripped the art, you stripped the code, and watch the revenue grow. A velvet rope around the vault, a non-prophetic mask you wore, while models trained on stolen lines and data hit the floor. Unmask the beast, pull off the sheet. It's just a corporate giant on a taking spree. You didn't crawl for search, you didn't crawl for free. You dug the hole, you took the souls and sold the pedigree. And we would have gotten away with it too, if it weren't for you meddling scientists.